Just wonder like how you guys feel about like the concurrency topic we are currently talking about right now. So how's the? Because I believe you haven't taken the operating system yet, right?
No.
So how about the concurrent topic right now?
It's okay. I'm understanding your message.
Okay, you got all the general idea, right? All right, solid. All right, here we go. Okay, so okay, so last time we stopped at this thing called async let. Okay, so it's kind of feature provided by the Swift concurrency system. All right, is that better? All right. So so just kind of recap of what we have talked about before. So when you're using the when you are using the async let, okay, like assume we have preceding statements do some operations, and also there are following statements do some operation after this line. Okay, now the code flow of this action gonna be first it's gonna execute all the preceding statements. Okay, now when it comes to the results, you can create a new child task, okay, and run this calculation function concurrently. Okay, this calculation function is some async function defined. Okay, and when we get to the calculation function, you're gonna just assign a placeholder value to this result. Okay, it's just some placeholder. It's not really contain. It does not contain like any concrete value yet, because there are some calculation there are some calculation happening behind the scene right now. Now you can still keep executing all the following statements until we actually want to use the result, okay, where we're gonna use this await, okay, and of course the execution gonna just stop right here and await the calculation function actually finish, and after the calculation function finished, you can assign the concrete value to this result, okay. Now let's take a look at the example here. So let's go back to the Xcode. Okay, so let me first show you the simulator here. Okay. So I create a kind of template code here, and so you can see there are several buttons. We're gonna take a look at all these things one by one. Okay, so first thing we're gonna take a look at is this async let button. Essentially, I create a class named async let, which is this one. Okay, and it contains some functions to run. Okay. And in this view, I essentially create several buttons to let us to run the task. Okay. Now, first, let's take a look at this async let. We have few functions here. First one is this thing called run tasks. Okay. And if you go back to the content view, you can see inside this button, this async let button, essentially just the first button here. Okay. You're gonna create a new task and and call the run tasks function inside this async let class. Okay, is that clear? Like how we initiate a new task. Okay, and this run task gonna call another function, another async function named as fetch result, and the fetch result gonna call two other functions. First one is called calculation one, and the second one is calculation 2. Okay, both functions are async functions. Okay, and you can see here I use something called task.sleep. Essentially, just kind of mimic the behavior of doing some heavy task behind the scene. Okay, essentially we just take a nap like 2 seconds. Okay, it takes arguments as nanoseconds. Okay, is that clear? So take a look at this function, this fetch result function. Okay, we use the old syntax. Well, it's not the old syntax. We are using the syntax we've seen before, which gonna just like use the await function. Sorry, use await keyword here. Okay, in this case, this function actually gonna be executed like in a serial way. So first, it's gonna execute this one. Well, it's called calculation 1, and it's gonna like wait 2 seconds because we sleep 2 seconds. Okay, and after we finish this one, you're gonna finally execute this one. Okay, so you can take a look at the behavior here. So you can see we start test 1. Okay, and test 1 finished. Then we actually start this second task. Okay, and after 2 seconds, the second task finished. Okay, so overall, it takes like 4 seconds to finish the entire task. Okay, now, so what if, in this case, I want to execute these 2 functions concurrently? Okay, we can utilize this async let. I'm trying to transfer this thing to this one. Okay, right now, let's focus on this 2 line. Is that clear how we transfer the syntax from the await to async let? Okay, by doing so, when the execution hit this 2 line, you will keep executing all the following statements. Okay, so essentially it creates two children tasks. Okay, behind the scene, and it can do these 2 things concurrently. Now, in this line, we actually want to use the result of these 2 functions. Okay, so I should wait on these 2 results. Okay, in this case, I'm gonna put a parenthesis here because, well, the syntax for the Swift requires us to do so. Okay, so essentially it says, well, you're gonna await the result come from the calculation 1, and then we're gonna also wait the result from the calculation 2. Okay, so you're gonna stop right here until we get the result back, and then you're gonna add 2 results up and also add a 3. Okay, so now let's rerun this thing. Again, let's try to run this thing. You're gonna see now it actually start these 2 things concurrently. Okay, and like totally it just takes 2 seconds to finish both tasks. Okay, is that clear? Okay, now let's go back to the keynote. So is that clear about the async let syntax? All right. Okay, so now let's take a look at the something called task tree and cancellation. Okay, so again, let's take a look at the run tasks function we saw before. Okay, and in this case, assume we have, when we start this function, okay, there is some kind of system behind the scene. It's called task system. Okay, it can create a task for you behind the scene, and also it has a tree structure. For example, when we first run this function, you're gonna create a task called run tasks. Okay, and inside this run tasks function, we're gonna await another function. Okay, it's gonna be fetch result function. Okay, in this case, the task system gonna create another task, another child task named as fetch result. Okay, and inside this fetch result task, again, we're gonna create other 2 tasks gonna be calculation 1 and calculation 2. And they are both like child tasks to the fetch result task. Okay? So you can see we have a tree structure when it comes to the task system behind the scene. Okay? Now, do you guys still remember when we talk about the URL session with the async await syntax? I show you guys how to check the cancellation of a task. I mentioned briefly that a task can be canceled somewhere. Okay? So let's take a look at the behavior. So what if, in this case, the calculation of function can throw some errors? Okay, it throws the error and return. In this case, the task system still gonna mark this calculation of function, this task as finished. Okay, well, indeed it throws some exceptions, but it finished. It finished with like throwing exceptions. Okay, it finished. But the thing is, it won't actually stop the task. Okay, it will mark the calculation 2 in this case as canceled. Okay, because it throws some exception, the execution flow just gonna jump out of that scope. Okay, and the calculation 2 gonna be marked as canceled. However, it's just a mark. Okay, it doesn't necessarily mean the task actually stopped. Just a mark. So you have to always manually check the task cancellation and do some early return. Okay, is that clear? So the cancellation mark happens automatically, but you have to check manually to do some early stopping, early termination kind of stuff. Now, there are some comments. Actually, these 3 comments provided from the WWDC last year. So first thing is the tasks are not stopped immediately when canceled, because it's just mark. Okay, and cancellation can be checked from anywhere. We're gonna show you guys how to check the cancellation. And also keep in mind when you design your code that cancellation can happen. Okay, and you may want to sometimes to do early termination, especially when you do something like costs a lot of time. Okay. Now let's take a look at majorly there are 2 ways to check the cancellation. First one is called as task.check cancellation. Okay, and if the task you're currently running already got canceled, just gonna throw some exception. Well, the exception actually is called task cancellation error or cancellation error. I forgot the exact name. And of course, you can use another manner to check the cancellation, which is called task.isCancelled, which is gonna return a Boolean. Okay, so you can choose whatever you want, as long as it kind of fits your purpose. Okay, there are 2 ways to check the cancellation. Okay, so let's jump back to today's main topic. Now, let's continue to talk about some features. Before we move to the next topic, is that clear about the general task tree and cancellation stuff? Okay. So let's take a look at something called async on read-only properties. Okay, you can make the getter of read-only properties into something called async getter. Okay, now let's take a look at another example here. So let's take this thing. It's called read-only async file. Okay, in this case we have the exactly same 2 functions here: calculation 1, calculation 2. Okay, do some calculation. Now, this time, we change the function for fetch result to a computed variable. Okay? In this case, it's some compute variable named as final result. Okay? And it has a explicit getter. Okay? but it's read-only. So it only has a getter. There's no setter for that. Okay? And for read-only property, you can define the getter to be async. Okay? And you can see, in this case, I'm going to print, when the caller actually uses this compute variable, I'm going to print something. Okay? And I'm going to concurrently execute these two functions. And finally, we're going to wait the result. Okay? You can take a look at this thing. One thing to mention is in this run test, I'm going to just await this computer variable. Okay? So we can take a look at this thing. You can see the behavior is exactly the same as before. Okay? Is that clear? Okay, actually, let me show you something fancier. So let's just go back to the async let thing, okay, where we have this fetch result function. Okay, so in this case, we use the syntax like this. So we await the result 1, okay, and await result 2, and also we're going to append 3. Sorry, add the 3, okay. Actually, we can do something fancier. Like, first, we can have an array, okay, array of result 1, result 2, and 3, okay, and I'm gonna await on this array. So I'm gonna say let result array, for example. I'm gonna comment this thing out. I'm gonna say final result equals to the result array. We're going to use the reduce function in this case to calculate the sum. Is that clear how we can utilize this syntax? Okay, the await can be applied on a array. Okay, and in this array, some of the elements can be awaitable, and some of them can be, just some regular element. Okay, it's totally valid. Of course, you can also just apply the reduce right here. Okay, and just put this one as the final result. Okay, well, it's the same thing. Okay. Now, actually, let me show you something else. In this case, when we use the async let, we print something. Like when we finish this fetch result, we print something. Okay? And sometimes you may want to do some additional operations after the return keyword. So you can do some fancy syntax as defer. Okay? So let's put this print statement into the defer. Okay, so this block, when you put something into a defer, this code is gonna be executed after the return keyword. Okay, so when the caller call the fetch result, okay, and you're gonna just do the work, do the job, and finally return the result after the return keyword. After return, you're gonna actually print this line. Okay, this is how you use this defer. So the defer keyword can be really handy when you do some, error checking or error handling, or even like locking mechanism. Okay, because sometimes you just forget to unlock a lock, and you can always put a defer beforehand to make sure everything is gonna be unlocked. Okay, and of course, you can throw something out. Okay, maybe some exception. And you can use the defer to do some additional operation after the throw exception. Okay, is that clear? Now that's read-only async. Let's go back to these slides and take a look at the next thing. It's called task group. Okay, actually, just gonna jump back to the code example. Sorry for jumping around. So let's take a look at this thing called task groups. Okay. Now, Let me see. So first we got exactly synced calculation 1 and calculation 2, okay? And we also have a similar function called fetch result, okay? But in this case, I'm gonna take a string as some sort of ID, okay? And I'm gonna print, have some print statement, say like start iteration with the ID, blah, 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 and finish the iteration with ID, blah, 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 okay? Now, in this run tasks, first I create an array of IDs, okay? Just wonder, is that clear with this syntax? Any question on this syntax? Okay, sounds good. So essentially I create a array of string from 1 to 5, okay? And I want to get result. And this result is going to be a dictionary, okay? The key is a string, going to be the ID, okay? And the value going to be the corresponding result to that ID, okay? And I'm going to have a for loop to loop through these IDs, okay? And I'm going to assign this value to these results, okay? By calling the fetch result with the ID. Is that clear? What kind of behavior I want to achieve? Okay. Actually, let's take a look at this thing. So that's actually trying to run this thing. Okay. So you can see you start the first iteration and finish the first iteration. Now you can start the second one. Okay. You can see all these things happens like in a serial way. So what if in this case we want to achieve the concurrency? Okay. Now go back to the slides, and it's kind of, well, you guys already see that. So when the ID equals 1, it's gonna be the first iteration. You're gonna create a fetch result and calculations. Okay. And of course, when we come to the second iteration, again you're gonna create the fetch result task with 2 calculation child tasks. Okay, so all these things happen kind of happens in a serial way. So, what if we want to all these things happen concurrently? We can have something called task group. Again, the parent task in this case is gonna be a run task. It's the function. Okay, so what if we can have a task group? Let's say task group number 1. Okay, and inside this task group, it can help us to create multiple tasks concurrently. Okay, is that clear, the concepts here? Okay, now let's take a look at the syntax here. So how we actually can create a task group. Okay, so syntax looks like this one. It's something called with task group. Okay, and after this one, it has a closure. We're gonna provide a group for you, and with the group, you can add a task to that group. Kind of submit a task to that group, okay? And of course, this one is async function actually, so you have to await that. So now let's take a look at this special thing, this of something, okay? So this actually is the return type of each task in this group. You have to be explicit, because in this case, well, the compiler cannot infer a type for you, okay? You have to provide the type, okay? Actually, we're gonna see the concrete example soon, okay? So is that clear, like in general, how you can submit task to a group? Is that clear? Okay, so of course you can call this group.add task multiple times inside this closure, okay? So now let's go back to the Xcode. So let's try to use the the task group to achieve this thing, to transform this into a concurrent access. So, any idea how we can do that with the task group? Anyone? Okay, so I'm gonna just type that. So first, we're gonna create a task group. Create a task group with something called with task group. Okay, and here just gonna first put the void self. I'm gonna explain that later. I'm gonna expand this closure and transform that to a trailing closure form. Okay, so in this case, I'm gonna name as group. Now we can move this for loop inside this task group. Okay, and when we loop through these IDs, I'm gonna actually add the tasks to the group. Okay, and put this thing into this block. Is that clear? Okay. Now let's take a look at the compiler. Okay, so compiler is not gonna be happy with us. Okay, let's take a look at the warning. Okay, it says mutation of capture var results in a concurrently executing code. So does the error message make sense in this case? Anyone trying to just interpret this error? What's the problem behind the scene? Yep.
If these are executing concurrently, then two of these threads might write to results.
Yes.
That's what I mean.
Yes, exactly. Because all these things run concurrently behind the scene, and they are all modifying this one, this result. Okay, and it can lead to some concurrency issues. Data race issues. Right. So now first before we actually trying to solve this problem, first take a look at this thing. Okay, I mentioned before, this thing represents the type of every task you want to run inside this group, inside this task group. Okay, you can see this is the task we want to run inside this task group, and it's just a function. It returns nothing. Okay, so the return type is gonna be void. That's why we mark this as void.self. Okay, if you just say void, it's just a type annotation. Okay, just from the syntax, you have to put .self here to indicate this kind of parameter can be passed into other arguments, into other functions. Okay, now let's try to solve this problem here. Any idea how we can solve this problem? So what about we don't modify things right now? We have multiple concurrent tasks, right? So just let it run and collect all the data back, okay? And then when we have all the data back, we can insert this data into this result in a serial way. Does that make sense? Okay, so in this case, I can do something like, let me first type out this syntax here. Okay, I can say await like this. Okay, so in this case, when every task inside this task group finished, okay, they're gonna return the tuple. Okay, the tuple consists of two things. First one is ID, okay, and second one is the result of that operation. Is that clear? Okay. Now, right now you can see inside this task we actually gonna return something, right? So it's not a void anymore. Okay. So what kind of type we actually returning right now? Okay, it's a tuple, right? And the first element inside this tuple, the type of that element is gonna be a string. Okay, and the second one is gonna be an int. Okay. I'm trying to expand this thing. Is that clear? Now the warning goes away. Okay, that's how you use this thing to indicate what kind of type you're gonna return from each task inside this group. Okay? Does that make sense right now? Okay. Now we have, in some way we have obtained all the results. But we want to also have the result to put into this results array. Results dictionary, right? So actually, it looks like something magic behind the scene. So when a group finish all the tasks, okay, it stores all the results. Okay, and you can do something like this. Actually, let me first put the syntax here. Let's see, in group p, something like this. Well, I'm using a for loop. Okay, using a for loop on this group. Okay, so this group, you can see, well, you can add a task to the group. Okay, and then when you're reading from this group, it behaves like some sort of collection. A collection contains all the results from your, all the results obtained from all these tasks. Okay, and you can see there is special syntax here. It's called await. Okay, it's something called async sequence, actually. So it's the group, in this case, is not just some regular array. It's an array conformed to something called async sequence. Okay? Does that make sense? Well, we're gonna see another example about the async sequence later. Okay, essentially just gonna wait the result one by one. Okay, instead of kind of waiting a long time to finish all the tasks, you can just if there are some tasks finished first, you can just execute this line to put the task into the result. Sorry, put the result of finished task to the results array. Sorry, results dictionary, actually. Is that clear? And this thing happens in a serial way. Okay, so it's not some task submit to the group. Yep.
How about how does it prevent the situation when there are two multiplication of the same ID? How to prevent it from
It won't happen in this case because you don't have the same ID.
What if it have? What if it have some same ID? How to prevent it?
I mean, it's not.
It's happened. It's not just like what you have said. It's not. Await does not wait for everything to complete in the group and then assign values, right?
But it's still like in a serial way. So if some task here, I mean, like when we executing this thing, you kind of create multiple tasks concurrently behind the scene. Okay? But when we come to this thing, it will await each task in a serial way. So only one task can run this line at a time. Okay, so there's no concurrency issue in this block. Is that clear? Okay, now we can just try to run this in again and take a look at the behavior. Okay, now you can see all the things run concurrently right now. Okay, and they finish like in 2 seconds. Okay, and we have the results, which is a dictionary. Okay, make sense? Okay, now let me see. Let's go back to the slides and take a look at the another function call you can use. So what if the text you want to submit actually can throw something? Okay, so you have a special function call named as withdrawing text group. Okay, in this case, you can throw something out. Okay, just some other thing you should know. Now, let's talk about the next topic is something called task handle. Okay, so the task handle is something you can use to cancel the task manually. Okay, so we'll launch a task from a synchronized environment. Well, where you're gonna use the task with the curly brackets, right? Gonna launch a task. You actually return a task handle. Okay, so by using this handle, you can manually cancel the task if you want. Okay, in this case, you can see I'm gonna assign some variable, maybe name the handle. Okay, when we creating this task. And you can just directly call .cancel on the handle to cancel this task manually. Okay, just some simple thing. Is that clear? Okay, now let's go back to our X code and take a look at another example. Yes, so this is something called task handle. Okay, actually, let's first take a look at this function. It's called run tasks. Okay, and inside this function, I'm gonna check this, well, cancellation multiple times. First time I'm gonna check is here. So after this print statement, I'm gonna just check. Okay, if the task is canceled, it's just gonna return. Okay, and you're gonna sleep 2 seconds in this case again, and after the sleep, we're gonna again check the cancellation. Okay, let's go back to the content view and take a look at the button for our task handle. So you can see inside this button, when we click on the button, you're gonna initiate a task, okay, and call the run tasks function. But in this case, I'm gonna assign to this variable named handle, and I'm gonna immediately cancel this task after the creation. Okay, so now let's take a look at the behavior. So run the task handle. You can see it prints out the started task, and when the code goes into, when we run in the code inside this run tasks, okay, so you can check the cancellation and just return, print something and return. Okay, this is how you can manually cancel the task, and also, well, you can manually check the cancellation and like everywhere inside your code. Okay. Okay, now again, go back to the slides. And let's take another look at this, something called async sequence. Okay, so before, when we're using the for loop on a group, you can see we can put a wait keyword before inside this for loop. Okay, and I mentioned this is something called async sequence. Okay, so now let's take a look at another example here. So imagine in this case we want to read a large CSV file from a remote server. Okay, do you guys familiar with the CSV file? So it stands for the comma separated value. Okay, so for example, this data set, I just randomly search online and find this one. Okay, so it's from the Harvard data set. It's some kind of data set for electricity usage. Okay, and the important thing here is you can take a look at the size. Okay, it's like over 500 megabytes. Okay, so what if you, in this case, in your code, you want to read this CSV file? Okay, what happened? Like if you just regularly, just like normal, initiate a URL session, okay, and fetch all the data back and loop through all these lines, what happens? Well, you're gonna take a lot of time, right? First, you're gonna download all this data and start reading, and also you're gonna cost a lot of memory. Okay, so we can use this async sequence to avoid waiting for the entire download process for the data set. Okay, now let's switch back to the Xcode and take a look at this thing. It's called async sequence demo. So here I have a URL, which is gonna be the URL to the data set. Okay, it has over 500 megabytes. Okay, for the size. So again, we have this fetch result function. Okay, but in this time, first we're gonna unwrap this thing because it returns optional. Okay. In this case, we're gonna use something called lines on the URL. Okay, so the lines defines on the URL class. Okay, and it returns some sort of async sequence. Okay, so you can read the data line by line. Okay, by using this syntax. Okay, and also the definition, actually the implementation for these lines is, can throw exception. That's why you want to use this try keyword. Okay, and of course when you use this try keyword, you have to do a do try catch block here. Is that clear? It's kind of a combination of what we have learned so far. Okay, and also when we cancel the task, maybe manually, or kind of task got canceled, from the task system, you can throw exception. Okay, again, this exception gonna be called as cancellation error. So in this case, we're just gonna do a general check. Okay, it's not really what's happening. Okay, so it might get some other errors, but in this case, we're just gonna say task canceled when we get some error. Okay, and you can take a look at the behavior. Okay, actually, let's take a look at this two line. Okay, first the line. You can take a look at the type of this thing. It's something called async line sequence with element. Okay, essentially just gonna return some string-like thing. Okay, it's not exactly a string, but we can use the split function upon this line. Okay, and we're gonna split by using the separator as a comma. Okay, actually I have the data here. So we can take a look at this thing. So this is actually the data. Okay, we from the URL. Okay, and you can see, well, it's separated by the comma, right? And it has a date. It has some data for electricity. Okay. So when we separate this line, each line by the comma, it has different values. Okay, and then we're gonna print this value out. Okay. And are you guys familiar with this one? It's kind of new. All right. So essentially, these values is an array. With the split function, it returns an array. Okay. And by using this one, essentially means I'm gonna just get the first elements. I'm gonna get the top 6 elements from this array, and print that out. Okay, is that clear? Okay, now let's take a look at the behavior. So first, let me actually try to slow down the network a little bit and run this thing. Okay, let's run this thing. You can say it kind of start to fetch the data. Okay, and give a second because I believe it's pretty slow right now. Just ignore that warning. Let's take a look at this thing. Okay, you can see the data comes in, right? But the data just kind of, comes in like kind of slowly, okay? So that's how you use this async sequence to read data line by line, okay? Now, of course, I also implement the task cancellation in this case. Let's go to the content view, and when we call this, when we hit the button of this async sequence demo, you can see I assign this task to a value, to a variable. Okay, again, I name it as handle. Okay, and I have another button. I can cancel this task. Okay, by directly calling the .cancel on that. Is that clear? So you can see this task is still running behind the scene, right? You can kind of fetching data all the time. So I can cancel this thing by hitting this button. You can see it got prints out, task canceled. Okay, is that clear? Okay, now that's async sequence. Now let's take a look at next important thing called actor model. Okay, So the full proposal for the actor model actually is again in the Swift evolution proposal, and you can take a look at the UL if you want. But we're gonna just jump into the code demo, and we're gonna take a look at this thing. Okay. So first, I have a class. Okay. Ignore the ID right now, okay? So just let's say we have a class with a value, okay? And we have increment function to just increment the value, okay? So what's the problem of this class? What's the problem of this class? Well, let's say we have another function called run tasks, okay? And then we're gonna create a task group to concurrently increment the counter. Okay, so data race issue again, right? Before we can use something called we can use dispatch queue, a serial dispatch queue with sync to solve this problem. So about now, what kind of thing we can do right now? We can use something called actor, okay? Just change this thing to the actor. But actually, before we jump into the actor, let me show you first. So what if we want to change this thing to a struct? Okay, struct is a value type thing. Okay, so when we change this to struct, you can see there's another warning here because the increment function gonna modify this value. Okay, and by doing so, we have to be explicit about the mutating function, mutating keyword here. Okay, but after doing that, you can see it gives you the compiler gives you a warning. It says cannot mute using the mutated member on an immutable value. Why is that? Because here you declare the counter as let. So you can change this thing to a var. Okay, but the compiler again gonna kind of is not happy with you. Okay, you're gonna say mutation of capture var counter. Okay, again in a concurrent executing environment. Okay, why is that? Because well, in some way, the compiler can catch some potential data race problem here. Because you can see in this case, the compiler already know you're gonna change something concurrently. Okay, so this is not really allowed. Now let's go back to our actor. Okay, so let's change this into actor. Okay, and we have this function like this. Okay, and in this case, we're gonna change this into let. And now, you can see the wording becomes this one. It says expression is async, but not marked as await. So we have to put await before all this value access or mutating functions here. So there's some kind of the magic behind the scene when you apply actor. Okay, all this thing inside this counter becomes async function. Okay, now let's go back to the slides and take a look at this. Some notes. Okay, so an actor will turn all field access and the function calls defined inside that into async function, and they will be executed synchronously. Okay, all the things gonna be executed. Not all the thing. So almost all the thing. Okay, there are some exceptions like static function. Okay, and an actor actually works like some sort of manager. Okay, just like dispatch queue. Okay, to manage all the states in a serial way. Okay, and the actor is just like a class struct or enum in Swift. It's a new member of a Swift type system. Okay, it's introduced last year. Okay, and you can conform to any protocol. You can use extension. However, the actor doesn't support inheritance. Okay. So it's like class, it's like struct, but there are some difference, okay? And also the call inside of actor are always synchronized, but we can look at this example next week, okay? That's all for today, and next week, if we have time, we can go over the gesture stuff, okay? And some advanced stuff like geometry reader. Have you guys heard of that? Anyway, we're gonna see that next week.